Okay, so we will start with the lecture. So yesterday, due to your that alumni session, we could not conduct it for more time. So just 1 minute. So yesterday, I have told you what is the scope for this optical communication subject and related to some basic things I have told. Okay, so some points through the study material I just want to discuss with you before we start the lecture. Okay, so some pictures are there in PPT. Some pictures are there related to the optical fibers and some related applications, so that you will get the overall idea. So that's why I have. Okay, just wait 1 minute. It is not on. Okay, so these are some of the pictures of optical fiber cable. Just wait 1 minute. This is the application of optical fiber cable for wavelength division multiplexing. आता जसं analog communication मध्ये आपण multiplexing बघितलंय, time division multiplexing and frequency division multiplexing. Similarly, in optical communication, there is wavelength division multiplexing. That is one of the major application of optical fiber. Then some another overall pictures I will show, and some interesting slides are also there. So some videos are there that I will upload in your study material, or I will send on your WhatsApp group also. So this is about optical multiplexing. So these are the some slides related to laser. Laser is one of the major optical source which is used. So how the light is emitted from the laser, that is shown in this particular picture. Then here in this PPT, you will be able to see the different type of LED structures. So this is the regular shape of LED, which we are using for practical application, that is dome shaped LED. So that points you will come to know at that particular chapter. Then these are the some slides related to optical network. So where the optical networks are used, why the optical networks are used, what is the reason, what are the advantages of optical network over the traditional networks, that is given in this particular slides. Then how the optical networks were developed, first generation, second generation, that points are here. And I just want to show you some pictures. I will just show you from internet so that you will get the idea about optical fiber cable, how it looks and what are its practical application. बघा आता इथे तुम्हाला दिसतंय सगळ्यांना, whether my screen is visible? Yes, online students, screen is visible or not?
Yes, ma'am.
Okay, so here this is one optical fiber cable. Here if you see, this is the, बघा आता इथं ही जर बघितली तुम्ही केबल, तर if you look visually it looks like our regular cable, but the internally the optical fiber it is used. Here also if you see, so here is one video related to that. So voice is audible to you of that video?
No, ma'am.
No,
Not.
not audible, no?
Yeah, ma'am.
Audible or not?
Video voice is not audible.
Okay. Okay, you just watch it.
Okay. Ma'am.
Okay, so here the single mode fiber it is shown that we are going to see in this chapter. Single mode fiber and multi-mode fiber. This is multi-mode. So it is transmitting more amount of light. You can see different modes are shown. So here is the application shown for fiber optic cable. Medical instrument it is shown. Okay, so optical sensors are also used in medical application for the precision based results. Okay, so whatever results we are getting, those are very accurate in the optical fiber sensors. Okay. Okay, so we will start with our point, whatever we were discussing in the previous lecture. So what point we have discussed in the previous lecture? Can anyone tell? Yes, which point we have started? This is chapter number 1 PPT. So up till now we have seen all the basic points. Ray theory of light we have seen. So what is the basic working principle of optical fiber? That 3 cases we have seen. कुठल्या 3 cases बघितल्यात आपण ऑप्टिकल फायबर मध्ये? Yes, what 3 cases we have seen? Yes, Audumbar, can you tell?
A refraction, reflection, and total internal reflection.
Yes, correct. So we have seen the first case, refraction of light. So this one. So in the diagram that 3 cases are shown. When light enters from one media into another, that is refraction. When it is some amount of light is absorbed, that is absorption of light, and reflected means in the same media it is again reflected back, that is the reflection of light. Okay, so we have seen that 3 cases. So as I told, for that purpose we are going to see these notes only for referring some diagrams. So बघा ह्या 3 cases आपण स्टडी केल्यात त्याच्यामध्ये. These 3 diagrams you are supposed to draw in the exam. Okay, so this one, it is refraction, critical angle. So critical angle means what? Can anyone define critical angle? काय definition सांगा critical angle ची? In optical fiber, what is the definition of critical angle?
It makes the angle of 90 degree with interface.
Okay, so it is the angle of incidence at core cladding interface. Angle of incidence at core cladding interface, for which the angle of refraction is how much? It is the angle of refraction 90 degree. See, these basic things are very important. So that's why I am repeating. These 3 cases we have to study. First काय आहे? Refraction. काय दाखवलंय त्याच्यामध्ये? This is one ray incident on core cladding interface and that is refracted at angle phi 2. Phi 1 is angle of incidence, phi 2 is angle of refraction. So N1 is core and N2 it is cladding. So what is the formula here? N1 sin phi 1 is equal to N2 sin phi 2. That is the basic formula for this refraction case. Similarly here, in first case we have seen as per Snell's law, as N2 is less than 1, phi 2 is greater than phi 1. त्यामुळे जसा हा angle of incidence आपला वाढत जातो तसा तसा angle of refraction it starts coming closer towards the core cladding interface, and at one incidence the angle of refraction becomes 90 degree. मग ती जी कंडिशन आहे ज्या angle of incidence ला angle of refraction 90 degree असतो, that angle of incidence is called as the critical angle. ह्या 90 degree ला पण critical angle म्हणत नाही. कुठं दाखवलं इथे critical angle बघा. Angle of incidence at core cladding interface for which the angle of refraction is 90 degree. Okay, so that is called as the critical angle. Then third, मग हा जर critical angle एवढा असेल तर ह्याला angle of refraction it is 90 degree. If the angle of incidence is greater than critical angle, then what will happen? It will be greater than 90 degree. And 90 degree पेक्षा जास्त म्हणजे तो परत कशामध्ये एंटर होईल? परत in which media it will enter? Core or cladding? What? Cladding. This N1 is refractive index of core. N2 is refractive index of cladding. Refraction मध्ये काय झालंय? आपण कुठलीही कंडिशन अप्लाय केली नाही, त्यामुळे तो कुठं केलाय? Cladding मध्ये. That we don't want in the optical fiber cable. So if you see the any picture of optical fiber cable, I will just show you some picture of optical fiber cable, how the light is propagating through the optical fiber cable. कुठलाही जरी तुम्ही ऑप्टिकल फायबरचं वर्किंग बघितलं तर इन एनी ऑप्टिकल फायबर ऑलवेज द लाईट इज प्रोपॅगेटिंग थ्रू कोर और क्लॅडिंग कोर. बघा आता इथं हा सिंगल मोड फायबर आहे, पण इथं लाईट कुठं प्रोपॅगेट होते, कोर मध्ये. दिस इज मल्टी मोड फायबर. हियर ऑल्सो द लाईट इज प्रोपॅगेटिंग थ्रू कोर अँड हियर ऑल्सो इट इज प्रोपॅगेटिंग थ्रू कोर. त्यामुळे आपलं बेसिक वर्किंग प्रिन्सिपल काय आहे की इथं बघा, when light is entering in the optical fiber, that should travel in the core itself. It should not enter into the cladding. मग त्याच्यासाठी ही टोटल इंटरनल रिफ्लेक्शन. इथं जर तुम्ही बघितलं तर हा रे कोर मध्येच आहे. कोर मधून तो इथं कोर क्लॅडिंग इंटरफेसला स्ट्राईक झाला. परत तो कुठं आलेला आहे, कोर मध्येच आलेला आहे. इथं परत कोर मध्येच आलेला आहे. मग हे कसं अचीव करतो आपण, ते करण्यासाठी आपण बेसिक रे थिअरी ऑफ लाईट स्टडी करतोय. मग रे थिअरी ऑफ लाईट मध्ये 3 केसेस आहेत. ही सेम डायग्राम डोळ्यापुढे आणा. इथं यू पुट दिस डायग्राम इन फ्रंट ऑफ युअर आईज टू अंडरस्टँड द वर्किंग ऑफ ऑप्टिकल फायबर. हा कोर आहे, इथं क्लॅडिंग आहे, आणि ही जी बदली लाईन आहे दॅट इज नथिंग बट कोर क्लॅडिंग इंटरफेस. सो हिअर व्हॉट हॅपन्स, this light ray strikes here and it is refracted in first case. कारण आपण तिथं कुठलीही कंडिशन अप्लाय केलेली नाही. अँगल ऑफ इन्सिडन्स काय आहे तिथं, कमी आहे. मग जसं जसं आपण अँगल ऑफ इन्सिडन्स वाढवत जातो तसं हा रे कुठल्या दिशेने येतोय बघा. आता हा समजा 30 असेल तर हा 40 आहे, हा 40 असेल तर हा 50 आहे, हा 50 असेल तर हा 60 असणार आहे. म्हणजे एक कंडिशन अशी येते की ज्या अँगल ऑफ इन्सिडन्सला आपला अँगल ऑफ रिफ्रॅक्शन किती होतो, 90 डिग्री. अँड दॅट अँगल ऑफ रिफ्रॅक्शन that angle of incidence for which the angle of refraction is 90 degree, that is called as the critical angle. Okay, that is the case. मग angle of incidence critical angle एवढा असल्यावर हा कोर क्लॅडिंग इंटरफेसला पॅरलल जातोय. Along that core cladding interface it is traveling. Now third case I have to consider, if I increase the angle of incidence greater than critical angle, मग हा पण 90 पेक्षा काय होणार, जास्त होणार. इथं हा 90 डिग्री अँगल आहे, 90 पेक्षा जास्त होतोय म्हणजे तो कुठल्या मीडिया मध्ये येईल, परत सांगा मला. इट विल कम इन विच मीडिया अगेन, कोर मध्ये येणार. दॅट आय वॉज आस्किंग. ओके, सो इट इज नॉट गोइंग इन टू क्लॅडिंग, इट इज कमिंग इन द कोर. त्यासाठी 2 कंडिशन कुठल्या केल्यात आपण. फर्स्ट, N1 शुड बी ग्रेटर दॅन N2. N1 जर लहान असेल तर हा इकडे येईल का, N1 कमी असेल आणि N2 जास्त असेल तर हा अँगल इकडचा कमी होणार. पण इकडे यायच्या ऐवजी तो त्या मीडियापासून काय होईल, लांब लांब जाईल. सो आय हॅव रिटन इन वर्ड फाइल ऑल्सो दॅट conditions for total internal reflection. If you remember, try to recall it. So 2 conditions we have seen. Conditions for, I will just write here TIR, conditions for total internal reflection. So the first condition is N1 should be greater than N2, and second condition is angle of incidence at core cladding interface. I will write angle of incidence at core cladding interface should be greater than which angle, critical angle. मग ह्या 2 कंडिशन सॅटिस्फाय झाल्याशिवाय लाईटचं टोटल इंटरनल रिफ्लेक्शन होत नाही. हा पॉइंट आपण बघितला होता. आणि this is related to the critical angle. So critical angle is related with core cladding interface, whereas the acceptance angle is related to core axis. आता रे theory of light मध्ये critical angle ही एक जी कंडिशन आहे, तसंच अजून एक अँगल ह्याच्यामध्ये महत्त्वाचा आहे रे theory of light मध्ये, and that angle it is called as the acceptance angle. That angle we have to see called as acceptance angle. So already we have seen, just I am revising because these points are important. If some of you were absent. तर हे जर पॉइंट नाही समजले तर तुम्हाला जे आता न्यूमरिकल घ्यायचे ते न्यूमरिकल सॉल्व करता येणार नाही. सो टू कंडिशन्स वी हॅव सीन, n1 should be greater than n2 and angle of incidence at core cladding interface should be greater than critical angle. Now third we are going to see acceptance angle. आता symbol लक्षात ठेवा. Though I am teaching from PPT, for drawing this particular basic diagrams in the exam, you please refer the diagrams from the notes. कारण PPT मधल्या पण diagram बरोबर आहेत, but there sometimes core cladding direction त्यांनी तिथं change केलेले असू शकते. So in that case you should not have confusion. So for this first chapter you refer the diagrams from notes only. I will teach from both, but standard diagrams you refer from notes. So this is the critical angle condition. Now the next we have to see, that is acceptance angle. आता acceptance angle चा concept कसा आहे बघा. Suppose this is the optical fiber. This refill it is acting as a core, and its outer layer it is acting as a cladding. So आता काय बघितलं आपण, इथून लाईट पुढे प्रोपॅगेट होती ती टोटल इंटरनल रिफ्लेक्शन ने प्रोपॅगेट होते आणि त्याच्याशी रिलेटेड जो अँगल बघितला दॅट अँगल इज क्रिटिकल अँगल. But apart from critical angle, there is one more angle present here, and that we are going to see, which is known as acceptance angle. बघा आता हा लाईट रे जेव्हा पहिल्यांदा ऑप्टिकल फायबर वरती येतो, at that time first it is making some angle with its core axis. Core मध्ये एंटर करताना this light ray it is making some angle with its core axis. And related to that, we have to see the concept of acceptance angle. See here. See this one. आता हे आपण इथं बघितलं की हा इथं टोटल इंटरनल रिफ्लेक्ट होतो. Up to this whatever we have seen, that we have seen this next part. बरोबर आहे, फायबर मधल्या गोष्टी बघितल्या आपण. But when the light ray is coming first on the optical fiber, it is making some angle with the core axis. When the light ray is coming on the optical fiber first, it is making some ray with the core axis, and this ray or this angle it is affecting on its next angle of incidence at the core cladding interface. कसं होतंय बघा आता. So already we have seen this point, so most of you might be clear with this. Just in 2 minutes I will repeat. बघा आता इथं एअर कोर इंटरफेस आहे, इथं कुठला होता, कोर क्लॅडिंग होता, बट दिस इज एअर अँड दिस इज कोर. त्यामुळं हा लाईट रे कुठून कुठे एंटर करतोय, पहिला मीडिया कुठला आहे ह्याचा, स्टार्टिंगचा एअर, एअर मध्ये ना तो 90% वी आर कन्सिडरिंग दिस एरिया एज एअर ओनली. काही काही एक्सेप्शनल केस मध्ये काही न्यूमरिकल्स मध्ये ऑप्टिकल फायबर इन्सर्टेड इन वॉटर असं दिलेलं असतं, तेव्हा फक्त तो काही वॉटरचा रिफ्रॅक्टिव्ह इंडेक्स येईल. हिअर 90% इट इज कन्सिडर्ड एज एअर. सो N0 is refractive index of air and that is equal to 1. So it is entering from air into core. So with this core axis it is making some angle and that is noted as theta A. Critical angles related upon particular terms, that is phi 1 phi 2. Here it is theta 1 theta 2 like that. So it is making angle with this as theta A, and here it is at air core interface it is refractive. इथं समजा हा अँगल 30 असेल तर हा अँगल काही त्याच्यापेक्षा कमी असणार आहे का जास्त असेल सांगा मला. आता स्नेल्स लॉ नुसार इथं काय होईल, N0 sin theta A is equal to N2 sin phi 1. आता एअरचा रिफ्रॅक्टिव्ह इंडेक्स जास्त आहे का कोरचा जास्त आहे सांगा. कोरचा. refractive index of any solid media is always greater than refractive index of air. So here the refractive index of core is greater than refractive index of air, and that's why this angle of refraction made here. आता इथं angle of incidence इथं measure होतोय 4 axis सोबत, and here also it is measured with the 4 axis. So if suppose this is 30, then it will be 20. हा जो आहे इथला रिफ्रॅक्टिव्ह इंडेक्स जास्त आहे, त्यामुळे हा अँगल काय असणार आहे, कमी असणार आहे. ऍज पर स्नेल्स लॉ, इन सिंपल वे यू कॅन रिमेंबर, ज्या मीडियाचा रिफ्रॅक्टिव्ह इंडेक्स जास्त आहे तिथला अँगल काय असतो, कमी असतो. सो हियर इट इज लेस. इफ इट इज 30, दिस इज 20. सो दिस रे विल गो हियर, आणि इथं हा टोटल इंटरनल रिफ्लेक्शन होतं ह्याचं. सो दिस राईट अँगल ट्रायंगल इफ यू कन्सिडर, हा जर 20 असेल तर हा किती येईल सांगा मला. इथं होतोय ना, ट्रायंगल होतोय ना इथं. इफ दिस इज 20, दिस वन, हा तर 90 असणार आहे. सो हाऊ मच इट विल बी, this ray I am telling you. If this is 20, and if you consider this triangle, इथून एक लाईन वर्टिकली होती ना, ह्याला एक नॉर्मल आपण ड्रॉ केले. सो दिस वन, इफ इट इज 20, इट विल बिकम 70. सो हा अँगल आहे, ह्याच्यावरून इथला अँगल ठेवतोय, हे लक्षात येते तुमच्या. आता हा जर 10 असेल तर हा किती येईल सांगा मला. सपोज हा 20, हा 30 आहे तर हा 20 आला. हा 20 आहे तर हा समजा 10 आला. हा 10 आला की हा किती येणार, 80. इफ सपोज दिस इज 10, इट इज 5, इट विल बिकम 85. म्हणजे इथला अँगल जर जास्त पाहिजे असेल आपल्याला ऍट कोर क्लॅडिंग इंटरफेस, तर हा अँगल किती पाहिजे, कमी का जास्त. हा अँगल इथला जास्त पाहिजे असेल. इफ वी वॉन्ट angle of incidence at core cladding interface as more value, then this angle should be less. म्हणजे लक्षात येते का तुमच्या. आता हा जर जास्त आहे, सपोज आता 30 पर्यंत बघितला, हा समजा 40 आहे. 40 म्हणजे काय, ह्याच्या बाहेर जाणार. 40 असेल तर हा 30 येईल, मग हा किती येईल, 60 येणार. मग क्रिटिकल अँगल जर त्याचा 70 असेल आणि हा इथला अँगल ऑफ इन्सिडन्स 60 असेल, तर तो पुढे रिफ्लेक्शन होईल का त्याचं. इथला अँगल जर कमी असेल तर टोटल इंटरनल रिफ्लेक्शन ह्याचं होणार नाही. इट विल गेट रिफ्रॅक्टेड अँड इट विल गो इनटू द cladding. That's why to have angle of incidence of more value, we want this angle of incidence here as a less value, and that angle we are calling it as acceptance angle. Acceptance कोण, हा जो शेप दिसतोय इथं तुम्हाला, ह्याला म्हणतात acceptance कोण. म्हणजे सपोज हा थिटा आहे 30 आहे, तर इकडे 30 डिग्रीचा एक अँगल काढायचा, इकडे 30 डिग्रीचा एक अँगल काढायचा, आणि हे दोन पॉइंट इथं जॉईन करायचे. सो द शेप लुक्स लाईक कोन, दॅट्स व्हाय इट इज कॉल्ड एज एक्सेप्टन्स कोन. ह्याचा अर्थ काय होतो, जर ह्या एक्सेप्टन्स कोनच्या रिजन मध्ये ऑप्टिकल फायबर किंवा ह्या एक्सेप्टन्स कोनच्या रेंज मध्ये लाईट इन्सिडेंट झाली, तरच पुढे त्याचं टोटल इंटरनल रिफ्लेक्शन होतं. आणि जर एक्सेप्टन्स इथं बघा, आता हा ए जो दाखवलाय तो ह्या कोन मध्येच आहे, त्यामुळे त्याचं टोटल इंटरनल रिफ्लेक्शन झालेलं आहे पुढे. पण हा जो बी आहे ह्या साईडला, तो एक्सेप्टन्स कोनच्या आत आहे का बाहेर आहे, बाहेर आहे. त्यामुळे काय झालं बघा, आता इथं हा अँगल इथला जास्त असल्यामुळं इथला पुढं काय झालं, तो इकडचा अँगल पुढं तसाच तो हे होऊन इथं रिफ्लेक्शन न होता हा कुठं एंटर झाला परत cladding मध्ये. And once it is entering into the cladding, it is eventually lost by radiation. So through radiation it is lost in the cladding. Okay, so this is about the acceptance angle concept. So you have to remember formula also for this. So what is the formula for critical angle? What is the formula for critical angle? Phi c is equal to sine inverse of n2 by n1. Phi c is equal to sine inverse of n2 by n1. Again, acceptance angle and phi c ह्याच्यातलं relation आपल्याला बघायचं सगळं. And that we are going to see in the derivation of numerical aperture. Now this point actually we have started in the previous lecture, but to understand this point, the basic revision of the previous points I have done. So I hope all of you are clear with that. Three conditions. First condition kai? N1 should be greater than N2. Then angle of incidence at core cladding interface should be greater than critical angle. And third condition I will write here, that angle of incidence at core axis, angle of incidence at core axis should be less than what? कुठलं बघितलं आपण आता इथं angle? Angle of incidence at core axis should be less than which angle? Acceptance. Don't get afraid. Please give the answers. Let it be wrong. Angle of incidence at core axis should be less than acceptance angle. Notation lakshat theva. Critical angle, that is noted by the symbol as phi c, and acceptance angle is noted by symbol as theta a. Now this next term we have to see. त्यामुळे एक्झाम मध्ये क्वेश्चन काय विचारला जाऊ शकतो? एक्सप्लेन द वर्किंग प्रिन्सिपल ऑफ ऑप्टिकल फायबर बाय युजिंग रे थिअरी ऑफ लाईट. त्याच्यामध्ये हे 3 पॉइंट लिहायचे. और इट कॅन बी आस्क्ड एज एक्सप्लेन द रे थिअरी ऑफ लाईट, or it can be also asked as explain the basic conditions for total internal reflection of light. So all these 3 points you have to write. Okay, is it clear? Yes, online students, is it clear? Okay. Now this numerical aperture we have started. Now basically the numerical aperture, its definition is asked in the oral exam. Numerical aperture stands for the light collecting ability of optical fiber. Light collecting ability of optical fiber, it is known as numerical aperture. So light collecting ability म्हणजे काय? Now suppose you consider this diary, if you consider this is optical source. It is emitting some light, and in front of that I am using optical fiber cable. Okay, actually this is having very large size. You just give your pen so that I can explain. Suppose this is the optical source. It is emitting light, and through that we are going to place optical fiber cable. Block diagram बघितली आपण. Information source, नंतर काय असतो? Optical source, then optical fiber, then optical detector, and then receiver. So whatever is this optical source, that rays are emitted by optical source, that are received by optical fiber cable. So whatever is the ability of optical fiber cable to receive the light emitted by optical source, that is called as numerical aperture. So it is defined as light collecting ability of optical fiber. I think I have told you to write down that definition. Light collecting ability of optical fiber, that is called as numerical aperture. So if we have two optical fibers, one is having less numerical aperture and one is having more numerical aperture value. So in that case, ज्याच्या numerical aperture ची value जास्त आहे, त्या fiber मध्ये light काय होईल? जास्त collect होईल. That's why when we are going to select the optical fiber, we are going to check all these parameters. What is its N1 value? What is its N2 value? What is its angle of incidence value? what is its acceptance angle value, then what is its numerical aperture value. So we have to perform practical based on this numerical aperture. आपल्याला ऑप्टिकल फायबरचं numerical aperture calculate करायचं practically. So here you first understand definition. It is defined as the light collecting ability of optical fiber. And we have to derive the expression for numerical aperture. So this numerical aperture, for deriving the derivation for numerical aperture, consider this diagram. So what is shown in the diagram? Simple case it is shown. Just light ray, it is incident on the optical fiber. This is core and this is cladding. This centered line, it is core axis. बघा आता ऑप्टिकल फायबरचा साइड व्ह्यू जेव्हा बघतो आपण, सेंटरला कोर ऍक्सिस असतो, इकडे कोर असतो, इट इज सराउंडेड बाय क्लॅडिंग. हियर ऑल्सो इट इज कोर that is surrounded by cladding. So this light, when it is incident on the core axis, the angle of incidence made by this light with this core axis, it is θ1. एक जनरल लाइट रे कन्सिडर केलेला आहे. It has incident with angle θ1 on the core axis, and then it has refracted in the core with angle θ2. इथं रिफ्रॅक्शनच होतं, इथं रिफ्लेक्शन होत नाही. रिफ्लेक्शन झालं तर परत तो एअर मध्ये रिफ्लेक्ट होईल. So here it is refracted in the core. Then again it is going next and at one point, at just 1 minute. And at one point at core cladding interface, it is getting reflected. ही condition इथं दाखवलेली. You understood the diagram first? मग this light ray is incident on core axis with angle θ1, refracted in the core with θ2, and it is again reflected in the core. That condition it is shown here. Then first we have to apply the Snell's law at air core interface. बघा आता Snell's law काय आपण अप्लाय केला? n0 sin θ1. As per Snell's law, refractive index of first media and sine of that angle. So first media is air. So just see this diagram once again so that you will understand this equation. See this diagram. First media is air, refractive index n0, angle of incidence θ1. Here angle of refraction θ2, and refractive index is n1. So n0 sin θ1 is equal to n1 sin θ2. पहिलं इक्वेशन बघा. n0 sin θ1 is equal to n1 sorry n0 sin θ1 is equal to n1 sin θ2. n0 is air refractive index, n1 is core refractive index. Then θ2 is angle of refraction at air core interface. But what is the formula for θ2? Or phi is equal to pi by 2 minus θ2. Means θ2 is equal to pi by 2 minus phi. So this theta we can replace by pi by 2 minus pi. Pi म्हणजे कुठला अँगल आहे? इथला. You consider this triangle. हा θ1 आहे, हा θ2 आहे, आणि एअर सॉरी कोर क्लॅडिंग इंटरफेसचा इन्सिडेंट अँगल किती आहे? फाय आहे. मग हा जर तुम्ही ABC राईट अँगल ट्रायंगल कन्सिडर केला तर हा किती असणार आहे? 90 डिग्री. मग हा आपण कसं बघितलं मगाशी, हा 20 असेल तर हा 70 आहे. म्हणजेच काय, 90 मधून हा अँगल मायनस केला की आपल्याला ह्या अँगलची व्हॅल्यू मिळते, किंवा 90 मधून हा अँगल मायनस केला की वी आर गेटिंग दिस पर्टिक्युलर अँगल. सो सेम वी हॅव युज्ड इन दिस derivation. So what is the first equation? N0 sin theta 1 is equal to N1 sin theta 2, means theta 2 is nothing but pi by 2 minus phi. So we can write here N0 sin theta 1 is equal to N1 sin pi by 2 minus phi. So but we know the basic equation. Sin pi by 2 minus phi means that is equal to cos. Basic trigonometry. Sine of 90 minus that particular angle is equal to cos. So cos phi. And again one more equation we know that sin square A plus cos square A is equal to 1. So from that here you can write this cos phi is equal to what? 1 minus sin square phi whole bracket raised to 1/2. लक्षात घ्या, आपल्याला कायम कुठलीही टर्म असेल इथं तर त्याला साइन फायसी मध्ये कन्वर्ट करायचं, कारण आपल्याला साइन फायसीचा फॉर्म्युला माहिती आहे. काय साइन फायसीचा फॉर्म्युला? यस वैष्णवी. वैष्णवी झोप यायला लागली काय? व्हॉट इज द फॉर्म्युला फॉर साइन फायसी? क्रिटिकल एंगल. Sin phi is equal to what equation we have seen? N2 by N1. Sin phi is equal to N2 by N1. That's why in this derivation always our try is to convert this angle in sine of phi c value. Okay. So sine of phi c ह्या टर्म मध्ये आपल्याला ह्याला कन्वर्ट करायचं. त्यासाठी काय काय केलं आपण बघा आधी. साइन थिटा 2 होता. थिटा 2 म्हणजे काय? पाय बाय 2 मायनस फाय. साइन ऑफ पाय बाय 2 मायनस फाय म्हणजे काय? कॉस ऑफ फाय. अँड अगेन वी हॅव यूज द इक्वेशन साइन स्क्वेअर ए प्लस कॉस स्क्वेअर ए इज इक्वल टू 1. मग आपल्याला जर कॉस फाय ला साइन मध्ये रिप्रेझेंट करायचं असेल तर कसं लिहू शकतो आपण? Cos square phi is equal to 1 minus sin square phi. So cos phi is equal to 1 minus sin square phi bracket raised to 1/2. हे सगळं जे आपण हे करतोय हे कशासाठी करतोय? कारण आपल्याला फक्त sin phi c चा फॉर्म्युला माहिती आहे. We don't know formula for sin theta 1 or sin theta 2. We know the formula for sin phi c. त्यामुळं हे सगळं केलंय. Sin pi by 2 minus phi is cos phi. Cos phi again we have represented as 1 minus sin square phi bracket raised to 1/2. Up to equation 3, is it clear? Yes, students. Is it clear? Audumbar, Swati.
Yes, ma'am.
So
It's clear.
sin square phi up to equation 3. Now next we have to consider the limiting case of total internal reflection. म्हणजे बाउंड्री केस जर आपण कन्सिडर केली टोटल इंटरनल रिफ्लेक्शन ची, तर बाउंड्री केस म्हणजे काय? The angle of incidence theta 1 will be replaced by theta A, acceptance angle, and this phi will be replaced by phi c. So when we consider the limiting case of total internal reflection, phi becomes phi c for core cladding interface, and also for limiting case of theta 1 or limiting case, this theta 1 becomes the acceptance angle as theta a. त्यामुळं limiting case जर आपण consider केली तर in equation 3 this theta 1 is replaced by what? Theta a, and this phi is replaced by phi c. So how the equation 3 is converted? n0 sin theta a is equal to n1 in bracket 1 minus sine square phi c. Now we know the sine of phi c. Sine phi c is n2 by n1. You write down somewhere. This is the formula for critical angle. Phi c म्हणजे काय? Critical angle. So sine phi c is equal to n2 by n1. Sine phi c is equal to n2 by n1. So this becomes n1 in bracket 1 minus n2 square divided by n1 square. So this is n1 square minus n2 square divided by n1 square. n1 square आणि परत 1 raised to 1 half म्हणजे इथं काय राहील फक्त n1. ह्याचं सिम्प्लिफिकेशन बघा जरा स्वतः ट्राय करून बघा. लेफ्ट हँड साइड इट इज सेम. n0 sin theta 1 is equal to इथं काय आलेलं आहे n1 in bracket 1 minus sine square phi c and bracket raised to 1 half. इथं बघा sine square phi c ला कशाने रिप्लेस केलं आपण. See this one. Sine phi c is n2 by n1. So this is 1 minus n2 square divided by n1 square and whole this bracket raised to 1 half. मग इथं काय येईल हे सिम्प्लिफाय केलं तर n1 square minus n2 square divided by n1 square आणि परत raised to 1 half आहे म्हणजे काय होईल इथं it will become n1. So these two values get cancelled. So n1 square minus n2 square bracket raised to 1 half. It remains. And then n0 sin theta a. So we get the relation as n0 sin theta a is equal to n1 square minus n2 square bracket raised to 1 half. So in this equation, you get the relationship between acceptance angle and refractive index of 4, refractive index of cladding and refractive index of air. N0 means what? Refractive index of air. So this equation is very, very important. And also in the exam, this derivation is asked for 4 marks. Derive the derivation for numerical aperture. So the next point is nothing but this equation 4 is nothing but it is giving the derivation of numerical aperture. So I will just write the next equation. See, Na is equal to n0 sin theta a is equal to n1 square minus n2 square bracket raised to 1 half. This is the only derivation of numerical aperture. So is it clear? So next steps are there additionally, but this is basic equation. Up to this at least it is required in the exam. n0 sin theta a is equal to n1 square minus n2 square raised to 1 half. This is the basic equation for numerical aperture. काय केलंय आपण ह्या डेरिव्हेशन साठी बघा. एक सिंपल रे कन्सिडर केला. त्याचा अँगल ऑफ इन्सिडन्स θ1 आहे. अँगल ऑफ रिफ्रॅक्शन θ2 आहे. आणि इथं अँगल ऑफ इन्सिडन्स ऍट कोर क्लॅडिंग इंटरफेस इज फाय. नंतर काय केलंय आपण इथं एअर कोर इंटरफेसला स्नेल्स लॉ अप्लाय केला. n0 sin θ1 is equal to n1 sin θ2, but then θ2 is equal to pi by 2 minus phi. Then sine of pi by 2 minus phi that we have written as cos of phi, and cos of phi again how you have written sin square phi plus cos square phi is equal to 1. So cos phi you can write 1 minus sin square phi bracket raised to 1 half. So like that we have done the conversion, and afterwards this phi c we have replaced with n2 by n1. So n0 sin theta 1 is equal to this. Boundary condition इथं आपण apply केली. So θ1 is replaced by theta a and this phi is replaced by phi c. So this one we are able to write it as n0 sin theta a is equal to n. हे जर सिम्प्लिफाय केलं तर काय मिळते आपल्याला this equation, and this equation number 4, it is the derivation for numerical aperture. Okay, so I will just show you the next notes. So this equation you have to write final. Na is equal to n0 sin theta a is equal to n1 square minus n2 square bracket raised to 1/2. So this is the basic derivation for numerical aperture. So is it clear to all? Yes, this side online students, is it clear?
Yes, ma'am.
आता इथं n0 ची व्हॅल्यू ही काय असते मोस्टली इट इज युनिटी. सो दिस इक्वेशन ऑल्सो वी कॅन राइट एज Na is equal to sin theta a. So in the numerical, acceptance angle is given and you are asked to calculate the numerical aperture. Like that it is given. आता इथं जे आहे पुढं हे बेसिक इक्वेशन आपण डेल्टाच्या टर्म मध्ये कसं लिहू शकतो हे दिलेलं आहे. So delta means what? That is relative refractive index difference between core and cladding. So that point we will see in the next lecture. Okay, is it clear up to this? Just you can go through this quickly. Theta is the relative refractive index. आपण नेक्स्ट लेक्चरला बघूया. आता फक्त कन्सेप्ट लक्षात घ्या. हा बेसिक फॉर्म्युला तर तुम्हाला लिहावंच लागतं एक्झाम मध्ये. अप टू दिस इट इज रिक्वायर्ड, mandatory, but some of the numericals in which the delta value is given. Delta stands for relative refractive index difference. So delta is given as n1 square minus n2 square divided by 2n1 square. जसा acceptance angle, critical angle हे जसे optical fiber चे parameter आहेत. Similarly, one more parameter is there in optical fiber which is known as delta. Delta is relative refractive index difference. Relative refractive index difference between core and cladding. कारण आपण काय बघितलंय, कोर आणि क्लॅडिंगच्या रिफ्रॅक्टिव्ह इंडेक्स मध्ये जास्त फरक असतो का कमी असतो? They are slightly different or they are having major difference value? Slightly they are different. If core is at 1.48, cladding will be 1.46. मग कसं काढतात डेल्टाची व्हॅल्यू? n1 square minus n2 square divided by 2n1 square. But this is almost equal to n1 minus n2 divided by n1 because delta is very small than 1. मग हे जर तुम्ही सिम्प्लिफाय केलं तर काय मिळतं तुम्हाला? n1 square minus n2 square is equal to 2 delta n1 square. हे इक्वेशन बघा. म्हणजे थोडक्यात आपण इथली n1 square minus n2 square ची जी टर्म आहे that we are going to replace in terms of delta. So what is the equation of delta? n1 square minus n2 square divided by 2n1 square. So what you get here? n1 square minus n2 square is equal to 2 delta n1 square. So Na is equal to n1 square minus n2 square raised to 1/2. मग ह्याच्या ऐवजी कशाने रिप्लेस केले आपण? 2n1 square into delta whole bracket raised to 1/2. मग ह्यात काय होतंय? n1 square raised to 1/2 म्हणजे काय आलं इथं फक्त n1 आणि ब्रॅकेट मध्ये काय राहिलं? 2 delta raised to 1/2. So this is one more form of the formula for numerical aperture. म्हणजे पहिलं हे तर बेसिक इक्वेशन आहेच आहे, पण one more equation you can write for numerical aperture in terms of this delta. So delta is equal to n1 square minus n2 square divided by 2n1 square. So n1 square minus n2 square ची व्हॅल्यू किती मिळते तुम्हाला? 2 delta n1 square and bracket raised to 1/2. So n1 square raised to 1/2 is equal to n1 and here 2 delta raised to 1/2. So this is the numerical aperture equation. Okay, so is it clear? समजलंय डेरिवेशन? हा पॉइंट काय रिपीट करायची गरज आहे का? उद्या डेल्टाचा कन्सेप्ट समजला? ती एक टर्म आहे that is the parameter of optical fiber. So you get two formula for Na. n0 sin theta a is equal to n1 square minus n2 square raised to 1/2 or na is equal to n1 2 delta raised to 1/2. मग इक्वेशन न्यूमरिकल मध्ये डेल्टाची व्हॅल्यू दिलेली असते, n1 ची दिलेली असते आणि na कॅल्क्युलेट करायला सांगितलेलं असतं. ओके, सो दिस वन यू हॅव टू यूज. ओके, so I think the time is over, so we will stop here. For any doubt you can ask me anytime. You can make phone call, you can message. Okay, so we will stop here. You just type your roll number in the chat box and you can leave. Just wait 1 minute. Wait 1 minute. Yes, you write your number in the chat box and you may leave the meeting.